All right, this is a video about the graphical method of adding vectors. Graphical means draw to scale, use a ruler, use a protractor, and the key to happiness is the phrase tail to tip. All right, so this particular question is about a softball being hit 60 miles per hour, 35 degrees east of north. There will be a wind blowing at the same time, 15 miles an hour, 10 degrees south of west. And so the question is, what's the resultant velocity and direction of that softball? So pick a place to start down there somewhere, because I have to go north-ish for a decent ways, 60 miles an hour. And pick a scale. Since the whiteboard is fairly large, and what I can do is use a scale that says 1 centimeter is 1 mile per hour. So I'm going to draw a 60 centimeter long line, and I will measure it to be at 35 degrees east of north. And that second letter, N, is what tells you what you'll measure your angle from. So this is north. I have to go 35 degrees to the east of it. So I will put the protractor right there like yay, and I will measure 10, 20, 35 degrees right there-ish. So the vector that I'm drawing is from there to there. This angle, 35 degrees. I need to draw a line that is 60 centimeters long. So I'm putting the 0 mark there, going up here to about 60 centimeters. And don't forget tips. That's what gives you direction. All right, now the second one I add is tail to tip to that one. So that's the tip, that's the tail. My second vector's tail needs to go at the tip of that one. So I'm going to put the second one right there. 15 miles an hour means I'm going to draw a 15 centimeter long line, 10 degrees south of west, meaning west is that way. I need to measure an angle that's 10 degrees to the south of it. So what I will do is put the protractor about yay, and a very shallow angle right there is 10 degrees-ish. And I need to go 15 centimeters, so 69 down to 15 is about yay. All right, so that right there, tail to tip. I put the tail of the second one at the tip of the first one. Boom. So the resultant vector, meaning the resultant direction and velocity that this softball goes, has a tail to tip rule also. You will start at the tail of the first vector you draw. You will go to the tip of the last vector you draw, and you will simply connect those two dots, measuring how long it is according to whatever scale you established. So I will connect these two like yay. And that's the 30, 60, so there's 30, 40, 53-ish, 51, 52, 53-ish centimeters long. That's ish 53 centimeters, which means it's ish 53 miles per hour is the resultant velocity. And then to get the resultant direction, it's just as simple as just measuring what angle this red line makes reference to north, south, east, or west. Since the red line is right next to north, I'm just going to measure how many degrees east of north it is by simply putting the protractor there, and it's 10-ish, 11-ish. You're not going to get more precise than that with this particular item. So that one is dancing around 11 degrees, and that is east of north. All right, so this then tail to tip graphical method, we just answered the question. It's really that simple. Don't overthink it. Draw a vector to scale that represents whichever one you want to start with. Tail to tip to that one. Draw the second one with the same scale to keep everything the same. So if 1 centimeter is 1 mile per hour, then that's 60 centimeters, that's 15 centimeters. Use a protractor to determine what direction it goes. Throw them tail to tip. The resultant now, the rule, tail to tip rule for resultants is tail of where you started to tip of where you ended. Connect those two, and since you drew it to scale, all you got to do is measure its length. In this example, it happened to be 53 centimeters, which means it's 53 miles an hour. And just measure what angle it's pointing. In this case, it was dancing around 11-ish degrees, and then give it some reference point east of north. All right, so there's the tail to tip method, and we'll show you the component method in our next one. Thanks.